Hi, everyone. Okay, do that. All right, so in the middle of the notes, but just a reiteration. Oh, here we go. Screen frozen already. Great. All right. Whoa, 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 whoa. Sir, say it. Sir, kicks or ticks. Okay, so just reiteration of that. Blah blah blah. You better get this down. And then we're moving on to 2-1, which is two separate, different concepts. And then we could call this one review. This is not really a new concept. Just having this triangle. And by the way, Pythagorean triples, right? 3, 4, say it. 3, 4. Oh my gosh, 5. How come one person only? Another one. I said it. 5, 12. Anyone? 13. 8, 15, 17. And then this last one, 7, 24, 25. Okay, but the point of this is actually, it is leading to concept 1. So we're really going to hammer this down real quick when we're done looking at this whole question. But this is review. If I looked at A, what does that make this side? What does that make that side that I highlighted? What's that called? That's the opposite. So it really changes, no, it establishes, I guess, the perspective of who is what side. This will always be the hypotenuse. By the way, you can't even play Sir Kicks or Ticks because you're not in a coordinate, remember the 3-second rule, coordinate plane. So we have to play SOHCAHTOA. Hey, everybody, or no one if it was first hour, because they don't answer questions ever. What is the sine of A? Screw you, Mr. S. I'm not answering your questions. 7 over 25. What's the cosine? What is this thing? Is that an arrow there? No, I didn't notice that little arrow stuck on that cosine. Look at that. See that little thing on that cosine, that C? Oh, I'll just continue. What's the cosine of A? We're not answering your questions, Mr. S. We have rights. What's the tangent of A? Stop asking questions. Why do you keep trying? 7 over 24. Oh, when I started my career, 95% of the students, 7 over 24, Mr. Samuelis. We love math. Now look at them. All right. Now let's change the perspective. Let's make B the reference angle. What does that make this side? What does that make that side? The opposite. And then that makes this side the adjacent. And then that makes this the hypotenuse. So what's the sine of B? Oh, Danny will get 24 over 25, Mr. Samuelis. Thanks, Danny. What's the cosine of B? 7 over 25, Mr. Samuelis. Thanks, Danny. What's the tangent of B? 24 over 7, Mr. Samuelis. Thanks, Danny. Okay, now let's notice something. So I gotta erase these I'm gonna erase these highlights because now I want to highlight a different idea. Whoops. Yeah, we filled that out, so we don't need that anymore. You saw it live. Hey, look at this. Did you notice that the sine of A ended up equaling the cosine of B? Huh? You see that? And the A and B are what kind of angle measures? Complementary. And then, of course, the reverse appears to be the truth. The sine of B ended up equaling the cosine of A. So vice versa. All right? Well, I wish there were some more. Like what I should have done is, what's the cotan of A? What is the cotan of A? Look at the tan of A and tell me what the cotan... No, they're not going to do it. They're teenagers. They don't listen to adults and answer their questions. Right? And then what's the cotan of B? 7 over 24. And there appears to be a similar relationship where the tan of A ends up equaling the cotan of B, and A and B happen to be complementary. And then vice versa, the cotan of A ends up equaling the tan of B. If you just try to look at these as one's the complement of the other one. The only ones I don't have up here are secant and cosecant. You'll just have to stick with me on that one. They have a relationship similar to that. And here it is. It's this idea. So I kind of, in order of the notes, if you looked online, this is towards the end of the notes, but I feel like I want to show it now because it kind of ties into that basic question that was reviewed that everyone should have been able to figure out. You should have been able to get all those ratios. But then from that, I can derive, or at least say, from this one example, it appears that the sine of an angle measure ended up equaling the cosine of its complement. That's what that 90 minus a means, right? Right. And then I said, oh, the reverse is true as well then. The cosine of an angle appeared to be the sine of the complement as well, so vice versa. And then I wrote cotan down after the fact to show that tan and cotan share the same relationship. And then you'll just have to, trust, and you can go back up there and we could prove it, but we won't, And it's not that it's a proof, but it looks like in this one example this is true. So we'll use that as an example of these identities and say that it is true. Okay, that's what an identity is. It's accepted as truth kind of idea. Just like a theorem or a postulate. A postulate's accepted as true. A theorem is proved to be true. That was our geometry semantic. Semantic means detail, the difference between the two. You will not believe what I just did. I think I just took attendance online. Oh my gosh, I just showed your faces on the internet. Oh no, I'm going to have to cut that part out. Okay. All right. Oh no, and guess what? I'm frozen. Let it go. All right. Okay, I forgot. I didn't pause. I paused the screen that projects, but I didn't pause the movie. So all that crap I was just talking about. Megan, you're online. All right. Oh no. I have to cut it out because you could sue me then putting your pictures on the internet. All right. So look at how stupid this question is. So by the way, did you notice that they were called cofunction identities? Here's a little mnemonic device, I guess. Not really. That's probably not the correct term that I want to use, but cofunction deals with. Anyone want to fill this in? Come on. At home, feel free to play at home if you're watching a movie. Say the word. Complementary relationships. Cofunction, the complementary relationship where the sine of an angle equals the cosine of its complement, and so on and so on and so forth. So we were talking first hour about, you have vocab in all these classes. I caught a student doing his Vietnam work he had his Chromebook out, staring at the Chromebook while I'm trying to teach this stuff. So of course, I made him shut it down. And we were just talking about vocab words for each class. This is, I guess, a vocab word. So what am I supposed to do when I read these directions? Who was cosine related to that we just did? Cosine was related to who? Sine. And it's sine of what angle measure? Not 52. Cosine of 52 doesn't equal the sine of 52. It's a sine of what? 38. They're complements. Who was tan related to from the relationship? Cotan. And cotan of who? No time. And then secant, the one we didn't prove, but it does work. I could have done it with the 72425. What's that become? Or who is that related to? No time, cosecant. You just look at the rule up there. And what's the angle measure? 66. Order 66. Anyone know what order 66 is? The destruction of the Jedi. Anyway. I'll press pause. All right. This is probably going to be. By the way, I think there is a quiz and then a test in this chapter. Not like the last one; it was just one test. Okay, because there is kind of newer stuff that I want to make sure you know how to do, and then add a few more things, and then a test. This is the number one missed question right here. Number one. Okay, so it just says find one solution. The reason they say that is there's an infinite amount of solutions that would work for this, I bet. Because of adding 360. What does adding 360 do? What is adding 360 on a coordinate plane? land you right where you started. Right? And I wouldn't know how to quite express that with this. There could be different ways. Oh, I know how I would do it. It's pretty easy. I could talk about that with this particular question. Okay, but it doesn't say anything. So then you're supposed to look at this and say, all right, what do I know about this? Are the two angles equal? Does the cosine of an angle equal the sine of an angle? You're a little early on this, but I think you understand no. They had some questions in 1-1 about that, or like one of the chapter 1s where they asked you to type in your calculator and make some conjectures about stuff. So no, that's not really true. What do you know about when the cosine of an angle equals the sine of an angle? What do you know about these two angles? They have to be what? 90. So just write what's true. This plus this must therefore equal 90 degrees. Absolutely. Now, don't listen if you don't care about this part. How could I get an infinite amount of answers? They could also equal, I'm having troubles, 450. Or, what did I just do to 90? Add a 360. So that's how you can get an infinite amount of answers. You wouldn't do that. I'm just saying, this is why they say, just give me one solution. You could just keep adding 360, and that would also be true. Isn't that crazy? But anyway, don't worry about that. I think maybe but anyway, do I really have to cover this the rest of the way? I mean, come on. We know how to solve from here, don't we? All right, right. Of course, there he goes. I'm not gonna teach factoring. All right, fine. I'll factor real quick and show you one more time for the 18th week in a row in our 18 weeks last year. Right? Okay. I don't know. A number? Oh, it's 21, isn't it? Now, what does that mean this angle measure is? What does that mean that angle measure is? 25. What does it mean that angle measure is? A number. 65. 3 times 21 is 63 plus 2. What's 25 and 65? Oh, nope, wrong. And then, isn't there a relationship with tan and cotan? If tan equals cotan, the only way that's true is if these two are what? So you add those two angles together, and I'm not going to solve this one. The number one missed question on the quiz or test are these, because people, they got to memorize these little blocks of information. And this is a random separate block that's not really related to anything else. All right? So that's probably the other thing. So I get the people that succeed are the ones that can memorize and remember these different little blocks or packets of information. True story, right? All right. Now to the real brass tacks. The real thing that's going to be important the rest of the year. And it is this concept. And I have always told you that this book is amazing. It is awesome. And you don't have to write this down like the words that they have here, but I want to give the book credit how great this book is. Love it. I love how thin it is, but how packed with information mathematically it is. Very efficient, logical math book. And I'll tell you, I've taught this forever. I've taught since my second year of school or teaching on pre-calculus, I believe. Maybe 1 or 2 years off in between. And Algebra 2, usually we have this. And I've always known the 30, 60, 90s, but I've never seen it broken down like this book does. So it wasn't until we got this book that I saw this and I wanted to share it with the students so that they understand a little bit better what's going on. So the first thing that you have written here, and I can't take this away, is an equilateral, also equiangular triangle. Just do it. Because when you go through this, you'll understand it more, and you'll understand why teachers say what they say about the relationships that are always true. So number one, make the sides 2, 2, and 2 so it mirrors some sides that you recognize. Number 2, drop an altitude in this equiangular equilateral triangle, and something special happens with that. In an isosceles or equilateral triangle, that altitude does two things. It bisects the opposite side, and it also bisects the angle that it emanates from. Ooh, what a word. So what does that make these angles now when I separate these into two triangles? What are those angle measures? 30. And what are these opposite sides right here? 1 and 1. So now I have two different 30, 60, 90 right triangles. Wrong. I have two of the same 30, 60, 90 right triangles with the exact same sides. How do you think we're going to find x? How do you think you're going to find x? Starts with a P and ends with Pythagorean. I have no time for this. The Pythagorean Theorem. So what do? I do 1 squared plus x squared equals 2 squared. 2 squared is what, class? Nothing. That was the first hour. Yeah. All right, and then what's 4 minus 1, class? 3. And then what's the square root of 3? What should I do to both? Oh, burn, baby, burn. What should I put in front of that? But why do we not put plus minus? Why do we only care about the plus? This is not in a coordinate plane. This is regular geometry. All lengths are positive. So we can put the plus minus there. I'm going to do it just because that burn happens all the time. But it really is just the positive in this case. And then therefore, here we go. How many people remember these ratios? I know it was quite a few because when I did those 1-1 notes where we had these ratios of sides, somebody said, hey, that's a 30, 60, 90. And a lot of us shook our heads, yes, I remember that. Well, now you're going to have to. All right? Sorry for that face that I'm making in class. Hey, I have a question. What do you think happens if I made this equilateral triangle? I'm just going to get rid of these right now. What do you think happens if I made this equilateral 4, 4, and 4? Then what's this side down here? 2. That's not rocket science. What do you surmise this side would end up becoming? 2 root 3. Do I have to prove that? Do I have to come over here and make this 4 squared and make this 2 squared? By the way, what's 4 squared? A number. What's 4 squared? 16. What's 2 squared? 4. This becomes 12. Do you know what the square root of 12 is? 12 is 4 times 3. What's 4? There you go. Do you see that? So what if I made it... Oh, you're going to hate this one. But it is okay. What if I made this 7? Let's just play the game. Oh, no. Fractionally, what is this one? 7 halves. And then what is this going to become? 7 halves root 3. And then what you eventually learned from your teacher was, you know what? Let's just variable this. If this was A, then this is 2A, and this shall be A root 3. Because it doesn't matter whatever A is, this is what's going to happen with every 30, 60, 90 right triangle proportionally. So, what's the easiest thing to do in the world? Just keep A as 1. And then we will have that original thing that we just did. A root 3, 2A, just 1 root 3, 2 times 1. Now I'll tell you, even after I go through this, and I'm taking so long to save those that do not be the students last year, that in 2 months still cannot come up with these sides. 2 months or more that still can't do the 30, 60, 90, 1 root 3, 2 times 1 thing. Another mistake they make. Why is 2 opposite 90 degrees? 2 is the... Put that comb away. Don't ever do that in my class again. 2 is the largest side. 2 is the square root of 4, which is bigger than the square root of 3. And then this is the square root of 1. This is just to compare these, because then another thing happens. People just start, flipping a 3-sided coin and just putting the sides wherever they want, because they don't even, the 2 is opposite the 30. The root 3 is opposite the 90. And that can't happen. That's just like juggling. Stop! I'm going to put those sides right there. All right? And then you have a 1 in 3 chance of being right on that. Common sense must dictate. Okay, so spending all that time to save those that need be saved. Okay, so here we go. Let's take this and do trig. And then you've already seen these ratios, and that's why people recognize in Chapter 1 the 30, 60, 90. All right, just like the first example, what's the reference angle? Well, if 30 is the reference angle, as you catch up, what side is that 1? It is the opposite. So it's all about the reference angle. So if this is the opposite side, this must be the adjacent because this is the hypotenuse. Always. And then the sine of 30, no one will answer it anyway. And if you don't know how to do this at this point, there's a problem. There is. So, ka, toa. Oh no. What's 1 over root 3 going to have to become? Root 3 over 3. And then you flip them. 2 over root 3 is 2 root 3 over 3. Again, knowing, and then this is another thing, people still not knowing that secant and cosine are the reciprocal. Now, I know I gave you a new thing. I gave you a complement relationship. This is the reciprocal relationship. Secant and cosine are together. Sine and cosecant are together. And, of course, cotan and tan are together. And then you may think I'm going fast, but it really shouldn't be a big deal. When 60 is the reference angle, then this is the opposite side, and that flips to the adjacent side. This will always be the hypotenuse no matter what. All right. Then the sine of 60, well, in this case, it's root 3 over 2. The cosine of 60 is a half. The tangent of 60 is toa, root 3 over 1. And then flip. And then we already rationalize over there, so we know that rationalizes to this, and we know that rationalizes to this. Give you a minute to take a breath. Did you notice that the sine of 30 equals the cosine of 60? What's 30 and 60? Complementary. Did you notice? Hey, let's take that cosecant finally. Did you notice the cosecant of 30 equals the secant of 60? There you go. There's a proof, not a proof, an example of the complementary, the cofunction relationship between secant and cosecant. All right, and then this is not rocket science at all. This is even easier. You don't have to split this triangle up. What kind of triangle is a 45, 45, 90? Right. But it's more than that. Isosceles. So if I pick a measure for one of the sides, then the other side has to be the same. That's opposite 45. Let's pick one. It's easy. All right? Just like when we go to a coordinate plane and we do the sine of 90, you go to 90 degrees and you pick 0, 1 as the coordinate that it goes through, which is the example I put as a reminder of that quiz that we just had. Test, but kind of like a quiz. Then I'm not even going to ask you, how do you find x? You do the Pythagorean Theorem. What's 1 plus 1? 2. I don't want to confuse you there. And then x squared equals 2, so what does x equal? Technically plus minus. And don't get confused with the letter x. This is not coordinate trig. This is just a classic unknown situation. What letter would that be in a coordinate plane? Not x, but what? R. So I don't want you to think, this has nothing to do with a coordinate plane. So just the variable of unknown. This is root 2. By the way, what if I made this side 2 and 2? What would this become? Well, what's 2 squared plus 2 squared? What's 2 squared? 4. What's 4 plus 4? What do you think the square root of 8 is? Don't touch that calculator, ma'am. What's the square root of 4? 2. That's 2 root 2. What if I made it 3? Then this would be 3 squared and 3 squared, which is 9 plus 9, which is 18. What's the square root of 18? Isn't there a 9 in there, right? What's the square root of 9? 3 root 2. Do you see how this works? A root 2. We are going to make a what, though, so our life is easy? 1. So it doesn't matter. That's why those in chapter 1, they recognize that one that was a multiple of a 30, 60, 90. All the sides were doubled. Okay. Anyway, what's the sine of 45? Well, that one's 1 over root 2. Which one? Wait, which one's the reference angle? It doesn't. Anyone? Matter. Because either way, you get 1 over root 2, which is root 2 over 2. And you're going to get sick of seeing these. This is what I mean about those that in 2 months still struggle with the ratios. To not know when I ask what's the sine of 45, you saying root 2 over 2, just by osmosis because you've written it so many times in your piece of paper doing your homework correctly. Is osmosis correct? I don't think that's the right use of that word. Anyway, sine of 45 is 1 over 1. Then flip these and you got the rest. And then flip 1, you still get 1. Nice. Wrong. That's the one. Use this. They're packing their stuff up, rightfully so, because I wouldn't even want them to write this down. But they do have this in the book. You know, this is like in a chart value. What are the trig functions of the 30s, the 45s, and the 60s in a nice little compact one spot? But doesn't matter. And then I did an example later, like it doesn't matter if I had a equilateral triangle that was 74, 74, 74. You know, that would be what the 30, 60, 90 would break down to. So I don't know. Blabbering now.